we have 4 points forming a tetrahedron. The volume of a tetrahedron is equal to volume of a tetrahedron is equal to 1/6 box of ABC, provided these 3 vectors represent the 3 sides of a tetrahedron taken in order. This means ABC will be like this, or either these 3 or these 3 or these 3. I hope you can understand. Taking any vertex, any point as a vertex. Tetrahedron is a very special type of geometric figure. This is 3 dimensional. Let me explain a bit. Let us understand the geometry of a tetrahedron. Now, if we nomenclate like this, this is O, this is A, B and C. Then OA may be written as A, OB obviously B, and OC is C. Then its volume will be 1/6 this. Why? It is more or less easily apprehensive, because what is box of ABC? A dot B cross C. Now, what is B cross C? Just see that this is B and this is C. So, what will be B cross C? B cross C will be mod B mod C sine of angle between B and C. So, obviously, this gives us the area of this triangle. Actually, the area of this triangle is half this, because if we take a minute look, then area of the triangle will be half base into height, and if this is C and this angle is theta, then the height will be C sin theta, and half B into C sin theta, half B into height, half base into height will be the area of the triangle. So, the area of the triangle will be half this. I hope I have been able to make you understand that the area of this triangle is half B cross C. Just see that this angle is theta, angle between B and C, and this is C. So, C sin theta will be the perpendicular from this point upon this base, and this is the base. So, half base into height is the area of the triangle. Now, why this 1/6? Because 1/3 of A dot this is the volume of the tetrahedron. Why? Because if we project the area upward, we are stacking this triangle. Similar type of triangle is being stacked. Then we get a solid which is larger than this. Actually, the volume of this tetrahedron is 1/3 of that stacked triangle BOC 1 by 1 upwards. BOC has this area. So, 1/3 A dot B cross C, half of B cross C actually, will give us the area of the tetrahedron. Why 1/3? Because if we stack the triangle upwards, we will get 3 times the volume of the tetrahedron. The triangle is getting smaller and smaller as we go upwards. And why this dot product? Because A side is slanted. A side is slanted to the plane of the triangle BOC. And what is the angle between this plane and this A vector? It is obviously the angle between the perpendicular to the plane of BOC and A vector. And so, in dot product that only occurs because B cross C has a direction perpendicular to the plane containing B and C, that is the plane of the triangle. So, now we move on how to calculate the volume of a tetrahedron when these 4 points are given. Now, there is a trick. Why? Because I will have to find A, B and C first of all. So, what will be A, B and C? We have 4 points given here. So, we will have to let me write it as A, B, C and D as these 4 points. So, the tetrahedron will be like this. If this is A, this is B, this is C and this is D, then obviously what will be A vector? A vector is dA, isn't it so? So, that will be the position vector of A, which is this, minus the position vector of D, which is this. So, it will be 1 2 3 minus 1 1 5. And what will be B and C? B will be DC or CD. Let us write it as DC because we are emanating from this point only. It will be symmetric and logical. So, what will be DC? DC is C minus D, C is 403 minus C is D is 115, and then we have lastly the C vector, which is represented by, let us say, dB. So, what will be dB? dB will be B minus D. So, that is 321 minus 115. So, to find the volume of a tetrahedron where the 4 points are given, I will have to formulate the figure in terms of algebra. This is very vital. Okay, I hope I have been able to make you understand that why these 3 sides are to be first found out with the basic concept of a vector. This you know from our early slides that dA vector will be the position vector of A minus the position vector of D, and it comes out to be 1 minus 1 0, 2 minus 1 1, 3 minus 5 minus 2. So, 0 1 minus 2 is the A vector, 0 1 and minus 2 is the A vector. Let us check. 1 minus 1 is 0, 1 minus A minus D, sorry, 1 minus 1 is 0, 2 minus 1 is 1 and 3 minus 5 is minus 2. Here also we have C minus D, that means this minus this, 403 minus 115. What will be that? 3 minus 1 minus 2, 3 minus 1 minus 2, this will be 3 minus 1 minus 2. You can again check 3 minus 1 minus 2, and what will be dB? That will be B minus D. So, what is B? 3 to 1. What is D? This. So, 3 minus 1 is 2, then 2 minus 1 is 1 and 1 minus 5 is minus 4. So, we arrived at ABC, and whenever we have ABC, we can easily write the volume of a tetrahedron with these 4 points as 1/6 of the box product of this ABC. A, B and C. So, what is the box product? The box product is 0, 1 minus 2, 3 minus 1 minus 2 and 2, 1 minus 4. So, it is very easy to calculate this determinant, and that will be the volume of a tetrahedron. Now, another one point I would like to elaborate is that why this box product is the determinant, or what is the basic idea of a box product. In my earlier slide, I have said that U dot V cross W represents U V W, the box product or scalar triple product of 3 vectors U V W. The order is very important here. Just see that if we keep this order intact and just shift like this, the order U V W is to be kept intact, but we can shift it. How we can shift it? We can keep W here, then U and then V. Just see that this is a cyclic order, U V W, here also U V W. Similarly, this is same as what? We can shift another point also, so that this V comes here and then came W and then came U. So, these are the 3 positions where the order U V W is maintained, U V W, U V W, U V W, but in all other cases this order is reversed. Now, let us write what is according to this is U dot V cross W. According to this, what will be it? It will be W dot U cross V. And what is this? This is V dot W cross U. I claim that they are all equal. Why? Because this is same as this matrix. If U, V and W may be written as 3 vectors having component U1, U2, U3, V1, V2, V3 and W1, W2, W3, then UVW box will be represented as the determinant U1, U2, U3, V1, V2, V3 and W1, W2, W3. So, obviously, this will be equal to V W U as well as this I have shifted U V W, the order is maintained, I have just shifted it U V W, and if we shift another position upward or rightward, then we get this is the final position. Now, I shift. So, this becomes VWU, this is UVW, and also another position is this W, U and V. So, this is same UVW, UVW. Okay. So, if we write this as a matrix form and this determinant form and this as a determinant form, they are same determinant. Now, let us take a look at why they are equal, both algebraically as well as from the geometric point of view. Just see that what is V cross W? We know that V cross W is ijk V1, V2, V3, W1, W2, W3. We know that. So, what will be U dot V cross W? Let us first calculate V cross W. V cross W will be I V2 W3 minus V3 W2, I times this plus J times we have in the reverse order W1 V3 minus V1 W3, and then K cap has component V1 W2 minus V2 W1. So, when I take dot product with U of this vector, what we get? We get obviously we get, see, U has U1 component with I. So, U1 will be multiplied with V2 W3 minus V3 W2, then U2 will be multiplied with J component or Y component. So, W1 V3 minus V1 W3, and U3 will be multiplied with the K component V1 W2 minus V2 W1, V1 W2 minus V2 W1. Now, let us write it after multiplying this. So, U1 V2 W3, then U2 W1 V3, and here if we write here U1, here if we write here U2, and here if we write here U3. So, just take note that what are the positive terms? These three are positive terms: U1 V2 W3, U2 W1 V3 and U3 V1 W2. And these are the negative terms. Why? Because 1, 2, 3, if they are just numbers, then we have these order maintained: 1, then 2, then 3 and then 1 in all these three positive terms. Just see 1, 2, 3. Here 1, 2, 3 in reverse order, here 1, 2, 3, but in all these cases this is not the factor. 3 then come 2 and then come 1, 3, 2. Okay. Similarly, this 1, 3, 2 and these 2, 1, 3. So, these are the even permutation and these are the odd permutation. So, they are positive and they are negative, and if we calculate the other two dot products keeping this order intact U, V, W, then same result comes. Let us see. So, whatever we written, we have written that U, V, W is same as V, W, U, and this in turn is same as W, U, V. but if we disturb the order, then we get a minus sign. Why we disturb the order? We write it like this. Just see, it is not the usual order UWV. So, this is minus. We can disturb the order here also, where I will have to write. How can you disturb the order? We can write it as U W V. So, this is also minus to these 3 values, and we can disturb this order also by writing W V U. See, they are also different odd permutations and they come with all a minus sign. So, why they are same? Because if we calculate by definition, what is this? This is V dot W cross U, and what is this? W dot U cross V. The parenthesis is not required. I have said in my earlier slide. It is assumed you have to calculate the cross product first and then the dot product. You can easily check that this and this as well as this will turn out to be the same value. This you can try your own, or I may write it at least a part for you. This is, what is this? The V is this. So, V1 I cap, V2 j cap, V3 k cap dot I j k W1 W2 W3 U1 U2 U3. So, obviously it will be V1 V2 V3 replaced here. Okay. You can easily understand. And what is this? This is nothing but W1 I cap, W2 j cap, W3 k cap dot I j k, and here U1 U2 U3 V1 V2 V3, because there was U cross V written here, and this will be W1 into U2 V3 minus U3 V2, then W2 into U3 V1 minus U1 V3, and W3 into U1